All right, we're diving into something pretty wild today. It's a radical new idea in cosmology that says the very fabric of reality, well, it isn't an empty void. It might actually be a flowing physical substance. So you've probably heard it, right? Physicists have been saying for decades that there's this crisis in cosmology, that our best theories, the ones we've relied on, are starting to crack under the weight of all these strange new observations. But what if that's just the wrong way to look at the whole thing? Yeah. What if all that weirdness we're seeing, from the absolute deepest reaches of space all the way down to the quantum realm, what if it's not a sign of failure at all? What if it's just the predictable behavior of a universe that's actually made of something? A substance that flows and spins and ripples.
Okay, so to really get why this idea is so compelling, you first have to understand just how big the problem is that physicists are facing. I mean, our standard model of cosmology, for all its incredible successes, is running into some serious challenges.
I mean, check this out. The James Webb Telescope, it's finding these huge galaxies that look way too old to even exist. And our measurements for how fast the universe is expanding, they just don't agree with each other. We're even seeing evidence that the whole cosmos is kind of lopsided, with a preferred direction of flow that just shouldn't be there. And of course, the big one. A whopping 95% of the entire universe is made of this stuff we call dark matter and dark energy, substances we have literally never seen or detected directly.
So for years, physicists have been trying to patch up these holes with new theories, maybe some new particles. It's like they're just adding new coats of paint. But this one framework, called SPANDA, it suggests we've been looking in completely the wrong place. The problem isn't the paint, it's the canvas. It's not the physics happening in the universe. The problem is our fundamental understanding of the universe itself.
And that brings us right to the core idea here. The SPANDA framework says, hey, what if space-time isn't just an empty stage? What if it's an active player in the game? What if it is a substance? Okay, so this is the huge shift in thinking. The standard view, the one we got from Einstein, is that space-time is this abstract grid, and mass just warps it. But this new view, it says, no, it's a physical medium. It's a kind of ultra-stiff superfluid. You can almost think of it like a cosmic Bose-Einstein condensate, which is this crazy state of matter where everything acts like one single quantum object. And if that's true, well then physics isn't just happening on the stage is the physics.
Now here's where it gets really cool. Just by making that one simple change in perspective, a lot of these big problems start to just click into place. So let's start with the absolute biggest one, that mysterious 95% of the universe.
You've seen this chart before, right? It's basically the standard recipe for our universe. For every single bit of normal matter that we can see and touch, there are roughly 5 parts of dark matter pulling things together and a whopping 14 parts of dark energy pushing everything apart. And we've always treated them as two totally separate, totally mysterious things.
But this SPANDA framework, it suggests that this whole dark sector is, well, kind of an illusion. It says that if the vacuum of space is actually a superfluid, that it has to have a structure, a kind of microscopic grid made of tiny spinning quantum tornadoes or vortices. And this lattice is what gives the vacuum its stiffness, its properties. And right here, the solution just snaps into focus. Dark matter, it's not some ghost particle anymore. It's just the kinetic energy of all these spinning vortices. It's the actual scaffolding that galaxies are built on. And dark energy? Forget about some mysterious repulsive force. It's the elastic tension of the lattice itself, the stored up potential energy that doesn't want to be stretched. Suddenly, the dark sector isn't dark or mysterious at all. It's just the mechanical stress and strain of the vacuum. And here, this is where it gets really compelling. There's this standard principle in physics called the virial theorem. All it does is relate the stored up energy of a system to its energy of motion. And when you apply it to a vortex lattice like this one, it predicts that the potential energy, that's the tension or dark energy, should be about twice the kinetic energy, the flow, or dark matter. In other words, the model just naturally spits out a 2-to-1 ratio between dark energy and dark matter. And guess what? That is almost exactly the 69 to 26% ratio we actually see in the universe. It's not a coincidence. It just falls right out of the mechanics.
Okay, so this idea totally unifies the dark sector. That's huge. But what about creation itself?
Well, it turns out this framework also gives us a whole new story for the cosmos.
from the very first instant all the way to the particles that make you, you.
So, according to the simulations of this model, the universe didn't start with a bang, exactly. It began as the state of pure high-energy spin. Then, this primordial rotation shattered. It kind of crystallized into that stable vortex lattice we were just talking about. This lattice then became the cosmic web, and matter started clumping at its intersections to form the very first galaxies. And if you zoom all the way down, you find that fundamental particles, the stuff we're made of, are really just stable little knots tied in the flow of this cosmic superfluid.
And get this framework completely flips our understanding of black holes. In this view, there's no singularity, no point of infinite density that breaks physics. A black hole is just a massive, locked vortex in the vacuum. Because it's a quantum object, its spin is quantized, which is a fancy way of saying it can't just spin faster and faster forever. It actually has a hard speed limit. So what happens when you try to spin it faster? All that extra energy has to go somewhere, right? The incredible shear stress right at the event horizon literally tears the fabric of the vacuum and ties it into new knots. And those knots, they are particles. So a black hole isn't a destroyer. It's more like a catalytic converter. It's an engine that takes in energy and spits out brand new matter in those powerful jets we see. And hey, that might even explain where those impossibly early galaxies came from.
Okay, so this reframes the dark sector and black holes. Pretty impressive. But it also goes after one of the absolute deepest questions in all of physics. Why are the fundamental constants of nature tuned to the exact values that they have?
I mean, in the standard model, these constants are basically just magic numbers. We measure them with incredible precision, but we have no earthly idea why they have those specific values. But in a hydrodynamic universe, they aren't magic at all. They're just properties that emerge from the fluid itself. The speed of light isn't some abstract cosmic speed limit. It's literally the speed of sound through the vacuum medium. The mass of a proton isn't just some number, it's the actual energy it costs to tie a stable knot in the superfluid. All of these fundamental numbers are just determined by the physical mechanics of the vacuum.
So when you step back and put all these pieces together, what you get is a completely new vision of reality. It's not a bunch of separate particles and forces floating around in an empty void. It's a single, unified, crystalline system. You know that beautiful cosmic web we see in deep space images? Those vast filaments connecting galaxy clusters across billions of light years? That's not just some abstract pattern created by gravity. In this model, you're literally looking at the physical, crystal-like structure of the vacuum itself. The galaxies are just lighting up the intersections of this underlying grid.
And this one single idea just starts knocking down all those other pesky problems. The Hubble tension? Oh, that's just the vacuum thawing out or getting a little less stiff over billions of years. That lopsided universe we talked about? It's just a fossil record, a leftover memory of the universe's initial spin. And even something as weird as quantum entanglement gets a physical explanation. It's a tiny little vortex filament, a tunnel that physically connects two particles right through the vacuum. So what are we left with? Well, it's this final, powerful thought. For 100 years, we've treated the universe like it's an abstract math problem, a calculation playing out on an empty stage. This new perspective asks us to consider a totally different reality, that we live inside a substance, a vast, vibrating physical medium, that the universe isn't some silent equation, but a ringing crystal, and we're just the vibrations within it.